Hey guys, so today I will show a little bit advanced reverse engineering, and also I will kind of try to show what augmentation or modification of binary software is in Windows. And if you remember, uh, I had a previous video where I kind of showed a very simple binary patch for my 8-bit game, which followed my blog post where I basically explained that I had a game that I wrote some time ago, and well, because of some silly thing that I, done myself, I kind of lost the source code, so I couldn't rebuild it, and I kind of showed how you can apply binary patch to this game. Again, this is in this video, kind of like really short. Now, in the example here, I did not have source code, but I was the author of this game, so I kind of knew what was where. And in my case, it was pretty easy. It didn't involve a lot of reverse engineering. So it was mostly about doing the patching, which is kind of like not very interesting. So today, we will be dealing mostly with advanced reverse engineering, or finding the location in the binary, how you can, basically location in the binary where you have to apply the binary patch, because the patch itself is not that difficult. So yeah, today again we'll do a little bit of advanced reverse engineering, and what I mean by that is when I'm the author of the code, it's pretty easy to know what, where, and how. But quite often in real life, you would have to work with something that you did not write, and in that case, you will have to spend most time reverse engineering it. Now, the problem in this case for me is how to do it legally. In other words, I can't take someone's program and start poking into it and changing it. So in this case, I kind of like wanted to do this for a while, and it took me some time to actually figure out, what shall I use? So what would be my subject? And I think I found what I will be working with, and this is Windows Snipping Tool. Now on Windows 11, it has been deprecated. I'm taking it from Windows 10. It's also present in Windows 7 and Windows 8 if you still have it. Now, if you go into a start menu and type in Snipping Tool, this will be the subject of my experiment. So let me, let me show you. This snipping tool here is technically deprecated, as you can see here at the bottom. So Microsoft gave up on it, and like the message suggests, they want us to use something else. So I will use snipping tool here as a subject for my reverse engineering and patching examples. Now, when I said augmentation or modification, I meant that the software that we have right here is something that is available, but we don't have a source code. Now, there are many use cases in this situation. For instance, the company, let's assume that this is not Microsoft, but some other company, went out of business, and at this point you don't have access to the source code and you can't modify anything, but something doesn't work. So in this case, you might want to, well, make that software work on a new version of Windows, or maybe you want to add something to it that did not exist before. Now, because you don't have source code, you have to do a binary patch, or in other words, modify what is available to you right now. So in my example, I will do probably 3-part series, because it's a lot of work, and I'll show it from beginning to the end, mostly reverse engineering part, how you can change this thing. Now, first thing that I will do, if let's say you make a snip, by the way, it's a snipping tool which basically makes a screenshot of your screen. So if you make a snip or a screenshot, as you can see, everything worked fine. But let's say you want to make another one, right? So if you go back and type in snipping tool and start another instance, well, it doesn't let you. You see, like if you go here, snipping tool, it basically limits it to just one running instance. Now, if you think you can create new, well, let's say click new and create a new snip. Well, guess what? The old one disappears without warning. So this is kind of ridiculous. There is really no point for this app to limit it just to one instance. So the first binary patch or modification, in this case augmentation, that we'll make, we will make sure that we can run more than one instance at a time. So that will be really handy, so that next time we can just run more than one copy of the program at one time. So this will be part part one. In part two, if you run the snipping tool, as you can see this thing at the bottom, let me just do a little bit of inception here. I'm using VM, and so I made a snip of the snipping tool. But as you can see, this bottom part is kind of like an ad, and technically we don't want to see it. So just for purely cosmetic reasons, I will try to kind of remove this part here so that the app is just the top part like it used to be. It's just like a silly example, but still could be useful in real life when you had to modify the UI of the app. So that will be part two of our series. And part three will be probably the most complex modification. Now, if you start the snipping tool, by the way, over here, let me remove it. What I've done, if you start it once and then right-click and pin to taskbar, you can just start it from here. Okay, but this is not the part of the part three. The part three will be something that will add to this program. Now, if you notice, when I start the snipping tool, I have to click the new button to actually start making snips, right? Which is a little bit inconvenient, especially if you want to make a snip quickly. So what I will try to do is I will add extra functions. So when you click, the snipping tool immediately starts making a snip. So in other words, when you click, it kind of clicks this new button. So instead of clicking it twice, I will make it once. So in other words, I'm not sure if I'm explaining it right. When you start the app, you don't have to click new, it kind of does it automatically, right? So you can then make a snip and have it ready. So that will be a three-part series. Again, reverse engineering is not something that, that's not exact science. It's something that takes time. And with this kind of like a long tutorial, I will try to show the process, how it works, how you get, first step, second step, and third step, and so forth, until you get to the final result. And at the end, I'll show you how you can do a binary patch, which is, again, the simplest thing in this case. Okay, well, guys, first of all, as I showed you here, as you can probably see, I'm working in a VM. Most of my reverse engineering work I do in the VM, including malware, obviously, and also including, legitimate software like this one. There are many reasons for that. I've written a blog post. If you go to my website, and basically explains how to set up a virtual machine for reverse engineering on Windows. Gives you all these apps that I'm using myself, so please review it. And as a result, this is, all the tools. Again, I'm not going over them in this video. Make sure to read this blog post. It will explain everything that I've set up here. And also, in case you are new to reverse engineering, I've written another blog post that kind of explains what you need to be a reverse engineer. Now, don't get immediately discouraged by, quite a lot of information here. In this tutorial, we will probably need some understanding of Win32 APIs, also understanding how to use some of these tools. Again, debuggers, probably detected easy, process, let's see, probably binary editor, Visual Studio, C++, and so forth. So again, please review my blog post about all this information. Okay, so let's begin. Now, first thing first, we need to understand how exactly this app is made. If you read my blog post, I believe it's this one. Oh, sorry, not this one, the one about setting up. There are two types of debuggers. I'm sorry, two types of binaries in Windows, kind of like a major classes, native ones, managed ones. There's technically a third one in case you are writing this thing with interpreted language, like Python, for instance. But in either case, we need to know how exactly this app is made. And to do this, we will be using a tool called Detected Easy. So to do that, we need to locate this file in the operating system. So here you go, Snipping Tool. Now, to make it more interesting for me, not interesting, but more easy for me, I will take it out of the System32 folder and I will put it in a separate folder. In this case, I will put it on a desktop. In your real example, I would probably put it somewhere else so you don't have a big clutter. And let's say test snipper, and I will copy it here. So at this point, if you drag our snipping tool into Detected Easy, it should tell us how exactly this tool was made. Let's see, for some reason this thing is kind of buggy. Okay, well, did I just, well, there you go. Sorry guys, unfortunately some of these things don't always work. So you just saw an example. Okay, so I'm not sure what happened to it, but we got what we needed. Basically, it's a compiler, C++. It tells you that this is a native binary, and that means that we will have to use native debuggers to actually analyze it. Personally, I will be using IDA. This is not my favorite debugger, but because it's really popular, I will stick to it. Now, I'm using IDA free, which means you don't have to pay for it, so it's not the expensive paid version. Okay, so at this point, since I moved it into a folder, I need to make sure that it runs. So when you double-click it, you get an interesting error message. Probably Mark Rusinovich would really get a chuckle out of this one from his series. I'm not sure if you watched him on YouTube with his stupid errors. To be honest with you, when I saw this thing, it took me a while to figure out what exactly is happening here. So I'm not going to reverse engineer this specific error. Now, to understand what is happening and what is missing is that the snipping tool is missing its multi-user interface component. Now, to kind of quickly explain it, I think in Vista, Microsoft separated resources from the binary and they put it into so-called movie files. I think it's this one. Okay, guys, let me double check. Oh, you know what? I am actually making a mistake. The thing what it's looking for is English US, because again, this is the locale that I have. And then if you go into English US, it's the file with the same name with the extension of MUI. So you need to put it here. And I believe, and what I'm doing again, I'm copying it from the System32. Okay, so this is what, it was missing. Obviously, it had this very crazy error, but, I guess someone didn't think that part through. Okay, so once we have this file, we should be good to go. Again, like when you run it, it should run just fine. Let me remove it here. Okay, well, as I just discovered by using Detected Easy, this is a native process. That is why we will be using a native debugger. So let's see what's happening internally. Well, first of all, when we run our debugger, it tells us right away this is AMD64 binary P file. It means that this is 64 x86-64 native file. So at this point, we can just click OK. Okay, it's missing something, so again, we don't have it. Now, in this case, we are actually in good situation because Snipping Tool is a Microsoft binary Microsoft app that is available on the Microsoft symbol server. So we can click yes here to actually look up its symbols. Symbols are very, very handy when you are reverse engineering something. Because you don't have to deal with a lot of like empty functions. As you can see on the left, it gave us a plethora of function names, which is really, really handy in this case. Because, you know, otherwise you would get just stubs like func something and then a number. So, and it definitely will save us time by having all this stuff here. Okay, well, as you can see, IDA loaded everything up, so let's add a breakpoint. And let's kind of think about it. So how do you approach reverse engineering? Well, a lot of it comes with experience. And in this case, if you remember part one, what we're trying to do, we're trying to allow more than one instance of the app to run at the same time. You see, like if I start one instance, and if I run something else, it just pushes this one back on the screen and doesn't want to run anything else. Now, from programming experience, I can tell that it is probably using some kind of named object, kernel object, that the first instance registers, and when the second instance runs, it notices it and refuses to run. So there are several approaches to it. One would be to look for a function that tries to invoke or call or create this instance of a named object. The second approach is kind of like a head-on approach and would be to actually step through the initial main function. If you look at the IDA, it gives us winMain, so we're right in the beginning. The reason the second approach, kind of like a head-on or brute force approach, would work is because if you look at it, it's right at the initialization, right at the get-go, the second instance gets canceled out or exits. So in my case, I tried the first approach, because if you look at Windows API, there's something called CreateMutex W. This is one of the native functions, so-called Win32 APIs, and at the end, you see it accepts name, which is it's called name mutex, and this name, this name is what makes it a named object. So in other words, if you try to create another object with the same name, it will give an error which says, you know, if the mutex with the same name exists, it will give you this error message. And an app can actually use this error message to determine if another instance is running. Now, unfortunately, with this approach, there is more than one named object. For instance, there is also CreateEvent. That is also a named object, so you know, technically they can be using it, and there are many more functions that also use this kind of like a named approach. In my case, I tried it and I didn't get any decent result. I was kind of like getting deeper and deeper into the weeds of it. So what I decided to do, I decided to just step through the beginning of the winMain and see what happens. Now, the technique that you can use is kind of like quickly go through and see where exactly the program terminates or exits. So, and this is what I'm going to show you. So the first thing I did, I put a breakpoint at the beginning of the winMain, and then I started it. Now, as you can see, I have one instance of the snipping tool running. So in this case, my second instance should quickly quit. So okay, let's try to do this. Okay, and as you see, debugger immediately stopped on WinMain. And in this case, I'm using this command, which is called basically step over. It will be stepping over all the calls that I don't need. Now, what you're looking at is the x86 64-bit version of assembly language. Again, this tutorial is not about assembly language. Again, check it out in other places. Again, there's a lot of tutorials on the subject, so I'm assuming that you kind of can read this stuff. Now, what I'm looking at are calls like this one, when it calls, well, in this case, another API, and it can also call internal functions. Like, for instance, you see anything in purple, it would be some system API, and anything in blue, that will be internal API, which is internal for this specific module. So in this case, like this part would be a mangled version that tells me that this is a C++ function. And in this case, debugger is pretty helpful by, unfurling or unmangling this madness here into a little bit readable C++ version. So in this case, what I'm doing, again, I'm looking at the calls and I'm stepping over those that I don't really care. Like, for instance, I don't care about registering event tracing or setting the heap information, or this one, which clearly is a constructor that Microsoft is using, something for evidently logging. And yeah, so I again quickly step through all of this thing and keep going until I see some information that can tell me that, okay, something happened and the program kind of took an unusual twist. Okay, so let me just show this in action. So in this case, again, we have one instance running, so our second instance should quit pretty quickly. So what I'm doing, I'm just kind of quickly stepping through. In this case, if I click on a call, let's see if it will. Oh, sorry, it doesn't highlight it, but I'm just going and seeing what is happening. So this part, again, I'm going really quickly through. Now, in case of a call instruction, I make sure to hit this button, which says execute instructions without entering into a function. Because if I enter into this one, I literally will go into a rabbit hole, because this API might be really, really deep internally. So, and because it really makes no sense for us to go through it, I just step over it and keep going. Okay, so in this case, it executes twice. Let me see, in case it's a loop, which it isn't, but in case it is a loop, what I can do, I can put a breakpoint and just keep going until it hits the breakpoint, because again, the loop, as you can see, goes to this location. And in case it's a long loop, I wouldn't want to step through all of it. So anyway, that's how you bypass it. In this case, I don't need this breakpoint. And let's keep going. Again, I'm not too interested in setting heap information. Again, this one, as you can see, is a debugger. So we step over it. Okay. I'm sorry, not debugger. What am I saying? It was a constructor for C++ function. And it seems like, yeah, they put the C logger everywhere. Here's another constructor, so we just step over it. Not interested. And I'm not sure why. Yeah, there's like constructor on constructor. Shows, yeah, kind of like leftovers of this C++. Basically, yeah, they're calling constructor. Here's destructor. I don't know if they're using macros or something. Something really interesting, some kind of permission here. I'm not sure what it is, but let's step over it. Now, if you remember the return, according to x64 calling convention, the return parameter from a function would be passed in RAX register. So here, evidently, we got a satisfactory permission, or it returned true. So again, kind of interesting. I'm not sure what exactly it was checking, but again, we don't care at this point. And let's see, there's a branch here. Let's see where it takes us. Okay. It seems like here it's querying some kind of policy. I'm assuming it could be something connected to GPOs on an Active Directory, but let's see what happens. Okay, we get 0. Now, guys, over here, it's kind of interesting. When you look at some function and it returns 0, it could be two things. It could be a Boolean permission, which you can kind of tell here by, well, the name. Now, Boolean for success would be 1, but there's also second option. And in this case, if you can see at the following instructions, like this test, which basically checks RAX or EAX in this case for its value, but then the next instruction, which is checking for the sign. And the sign instruction, when you see this kind of combo, it tells you that most certainly the return value was something which is called HRESULT. And HRESULT is a Microsoft return value. Basically, if it's 0 or SOK, that will be that the operation succeeded. If it's anything negative, as you can see all of these values, that would be an error. And if it's a positive but not 0, that would be a warning. And you can tell by presence of this test and also the signed jump. So in most certainty, this tab query policy value returns an HRESULT. So in our case, because we got 0, it means that, and again, you can see that this is 0 because RAX is 0. You can tell that it went through, so we got some kind of success for the policy here. But again, that's not anything that we're interested in. Let's just keep stepping. Okay, now this one is a destructor for their logging function. And let's see what is happening here. Now, this part is kind of interesting. Now, again, if you know IDA, this part here. So here, guys, if you know IDA, it highlights in this kind of pinkish purple color all system APIs. Now, this imp part, it's kind of like, well, a rudiment of Microsoft compiler. Again, you can find it on my blog, in one of my blog posts. But the important part is this. So if we do copy and actually search by what this thing is, it's a comparison, string comparison function. And what it does, it literally compares two strings, which is kind of interesting because if you see what it's comparing, if you see like first, second, third, fourth, and fifth parameters are the actual strings. So over here, now if you know x64, 86, 64 calling convention, and up it a little bit. So the way it passes parameters is that it goes RCX, RDX, R8, R9, oops, R9, and that would be first parameter, second parameter, third parameter, fourth parameter for the function, and then the fifth parameter goes, it goes as part of the stack, and so forth. So in this case, we are curious about, so 1, 2, 3, third, and fifth parameters. So R8 and the stack parameter. So if you look over here, oops, sorry, don't have to double click. R8 is a string. Now the stack parameter, let's see, let's see, where does it have? Actually, the IDA is kind of helpful here. It gives us these comments, I guess, on the right. And as you can see, R8, again, our third parameter, which is, again, if you bring up the actual API, let me just up it a little bit. So the third parameter is one of the strings that it compares to, and as you can see, it's comparing it to something /clip, which kind of tells me right off the bat that it's looking for a command line parameter. But the other one, it's actually getting here, which is R14. It puts it into the stack. And what happens with the stack is that it uses RSP plus 20. And if you know calling convention, again, this is not tutorial about like the calling convention, but it creates this kind of like a hole here, which is called shadow stack. And it skips RSP plus 0. It skips RSP plus 8 because it does the alignment by 8 bytes. RSP plus 10. RSP plus 18. So these would be a shadow stack, all 4 of these. So it's kind of like a scratch area for the compiler to use internally for these 4 slots, because it passes them in each of these registers, but it starts using the actual stack from this position, so RSP plus 20. And now, unfortunately, IDA is not very helpful with this BS here, but what it's doing, again, let me just show you real quick. So if you go into General and make it display machine code, so then we can take this instruction here and we can go online to any of online disassemblers, and let's just use this one. And in this case, if we select, oops, sorry, wrong location, we're disassembling. So what we're getting here is this instruction, which is RSP plus 20. Now, unfortunately, IDA shows us this BS here, so I'm not sure it's trying to be helpful here. I'm not sure what this plus D0 is, but this instruction here is move RSP plus 20, but RSP plus 20 is exactly the 5th parameter. And this is what we need. So let me remove machine instructions, like so. Okay, so what we need to see is where exactly it's taking this R14 from, because it's writing it here. So if I click on it and scroll up, it should show us where R14 is coming from. So if we keep going all the way up, you see that R14 is actual parameter that is passed into WinMain. And R14 is copied from R8. And if you look at R8, this is the 3rd parameter that is passed into the function. So in other words, R14 is the 3rd parameter that is passed into WinMain, which is like 1, 2, 3, and this is our pointer to our command line. So just as we assumed, by the way, if you want to return back to to the instruction, you can right-click and go to jump IP. That will bring you back to your IP address. Okay, guys. So what this seems like to be happening is that this instruction is checking if the parameter, the command line parameter, is clip. Now, this is kind of interesting. Let me copy it, because I did not know that the snipping tool can actually accept a parameter. So what we can do let me put a breakpoint here. And I want to test what happens when you run a snipping tool with the parameter. So let me kind of like pause this for a little bit. This is part of reverse engineering, kind of like finding interesting things. So let's see what happens when you run snipping tool with that command line parameter. Now for that, let me open a command line and try to run our snipping tool with this command line. Let's see what happens. Oh, interesting. So it lets you make a snip without showing UI. It's kind of like, like really fast way of making a snip. Interesting, but what happens to it? Oh, is it copying it to, yeah, let me try. I think it's copying it to the clipboard. Let's see if we copy this part, and if we go and find paint and paste. Oh yeah, really cool, look at that. So when you run it with the clip command and make a snip, it copies it to the clipboard. Let me just double check again. Yeah, sure enough. Wow, interesting. Well, guys, this is how you can find things. Let me see if this one is actually known. Maybe somebody else found it. Let me just do a quick Google search. Snipping tool. Did Microsoft really document it? Create snip. Maybe it is documented. I don't know. But anyway, guys, I'm not gonna I'm kind of curious if you know if that is a well-known fact that you can provide a snip. Is it snip? No, clip. Oh, clip. Command line parameters. So I'm not sure if it's even known. But the interesting thing that what we can do if we create a shortcut, and let's call it fast snip, and then if we go into properties for that shortcut and basically use our command line and put it right here, and run it, so we can technically have a shortcut where we can actually make a fast snip. So as you can see, this is the benefit of reverse engineering, where you can actually find something that might not be documented or something that you might not even know. But anyway, so here's something that we found, and well, let's get back to what we were doing. At this point, because we have a breakpoint, and if you look at the breakpoint window, if you have it, I guess I don't have it here. Let me see if I can locate it. Debugging breakpoints, breakpoint list. Okay, we have 2 breakpoints, and as you can see, the second one is over here on our. Okay, well, it's virtually impossible to see it. Let me change it to this one. So the breakpoint is on our compare string. So this will help us to skip all those single steps that we were performing before. Let me show you how you can do it. So first one is obviously on a win main, so we don't care about stepping through the rest of the stuff that we witnessed before. We just run, and we get to our compare. Obviously that will not compare, it returns 3, which I believe, look at the documentation, and okay, we have to look at another API, but I believe it returns 3 values. Yep, so less, equal, then. Unfortunately, Microsoft is not very helpful. If you read my blog post, I usually employ Visual Studio to resolve these parameters. So what I do, I copy it because I need to know a value of this C string equal. And if you start Visual Studio, I usually start a very simple C++ project, and I just paste into it. And then what you can do, right-click and peak definition, and as you can see, 2 is equal and 3 or 1 is not equal or less than, but that's basically what it means if it's 1 or 3. In our case, the result is 3, which means they're not equal. It means it's going to step somewhere. And let me see. Oh, interesting. So it is creating a mutex. Okay, so this might be our function that we were looking for. But what I just noticed, we do not have another instance running. So it's kind of like my bed. Let me close the debugger. And I'm using the stop command to kind of like kill it. And let me run. Oops, not this one, sorry. Let me start one without our snipping, our clip command line. So again, we started another instance. Again, have to do the same thing. So we run, wait for it to hit the first breakpoint. Then we need the second one. And let's see what happens. Because these steps are pretty repeatable and it doesn't take me long to actually see, you know, to actually get to this point, usually when I see something promising, I kind of like step over it and see the result to kind of like tell me, okay, what is happening here. So let me step over it and let's see the return value. The return value is 138. 138 could be interesting thing. I'm not sure what it, oh, it could be, oh, okay, like you can see over here, IDA actually is helping us because it saves this result somewhere. So as you can see, it says void pointer, which tells me that this is a handle. So it means that we opened our mutex here. And the reason I know that this is mutex is by the name of the function. But let's see what happens. As you can see, they're checking for get last error, and which is nice. And let's see what the get last error would return us. So if you look at the get last error in MSDN, they have really good explanation what happens, but basically it returns last error that the API returned. Let's see what kind of last error we get. And we get 0, which is kind of interesting because we have our app running here. So technically, if you go into CreateMutex, we go back to the documentation and scroll down. Over here, it says that if the mutex already existed, it will return this thing, which is error already existed. And again, to get the value, I go back to Visual Studio, paste it in here, and look up its value. So in our case, the value would be 183, but this is not what we got here. Let me put it here in my notepad so I can kind of keep it. Okay, this is interesting. It created it, but the get last error is 0, which tells me that this is probably not what we're looking for, even though this was very promising. Well, let's see what happens. So, okay, it's checking for B7. Let's see, what is B7? Now, as you can see, the value is in hexadecimal, so I'm using calculator to quickly convert it. And B7 is 183. And this is exactly what this error code is. So it is checking for error already exists, but what we got is actually 0. Okay. This tells me that this is not what we were looking for, and we need to keep going. Okay, so we hit another function, which is called BringSnipperToFrontIfAlreadyRunning. Interesting. So as you can see, having symbols is very, very helpful because we found something that is quite promising. At this point, let me step over it, because again, instead of going through internals of this function, let me just step over it and let's see what happens. And I don't know if you noticed, but when I stepped over it, my snipping tool kind of quickly came to the foreground and then went away. So this part is very, very promising. Now, as you can see, the return value is 1. So let's document it. So return 1. And let's see what happens next. Okay, we get some kind of trace logging here, which is not interesting. Log launch. Again, some kind of trace logging here. Okay, then it's checking EBX, and EBX, as you can see, came from here, which is result of running of our interesting function that, again, we documented here. So EBX will be 1, that we can confirm here. And if EBX is not 0, oh, interesting, it releases the mutex, jumps, closes the handle, and let's see what does it do next. It starts calling. Yeah, guys, I think, yeah, you see it starts unregistering things and does it twice. If you remember, in our initial stepping through, it did it twice, so it unregistered it twice. It seems like it's winding down. Oh yeah, and it's returning from WinMain. Yeah, here you go. So we're in CRT. Yeah, so if I continue running, yeah, it pretty much exits. Interesting. So it seems like our function over here is what we were looking for. So next step that I would do, I would close this instance and try to run again. In this case, being my running of this app will be the first instance. So let's do this again. Our first breakpoint on WinMain. We get to the second breakpoint of compare string, and we just quickly step over it. Now this one is, okay, we'll create mutex, something that probably doesn't affect us. Get last error, again, is 0. It means it's working. Okay, and this is the function that we were interested in. If you remember in our notes, last time it returned 1. But let's see what happens this time if we step over. And it returns 0, right? As you can see here in RAX. And let's see what happens. So it does some kind of trace logging, log launch. Again, it's some kind of trace logging stuff. It steps over here. Oh yeah, look at that. So this jump here is what makes the difference. You see, like now it registers the application for restart and goes here, starts doing, operator new, creates classes probably, and yeah, starts doing all kinds of stuff here. Let me see if I keep running. Oh yeah, it continues running. As you can see, yeah, we started the instance. Okay, well, this tells us that this is the function. So the next step would be to actually step into it and see what it does. Again, we start over. As you can see in reverse engineering, you have to go through many iterations. When you start an app, you terminate it, you start, you terminate. And what you do, you continuously update your breakpoints. Like this one, I don't need anymore. So let me get closer to the function of interest. And let's see, I'm going to put one over here so that I can quickly get to it. Okay, well, in this case, we're doing step in, execute each instruction. So in other words, step into this function. And let's see what it does. Oh yeah, I can tell right off the bat, it is using find window. And if you look in find window API, What it does, it's using window classes and window titles to look up the H window or handle of a window. And in our case, if we, well, sorry guys, let me close this thing. And again, I forgot to start our snipping tool. You know what, for now, let me remove this pin and use this one, the one that actually shows the app. Okay, so let me kind of explain real quick what this find window is. So there are two things that you can use to find window, using its class name and using window name. Now class name, oh man, this thing is annoying. Class name has nothing to do with like C++ classes. This is window class, kind of like a Microsoft invention. This basically defines the window procedure that is used for this specific window. And you can use both or one of these to actually locate the window. And the interesting thing here is that we need to know what is the window class of our snipping tool. The easy way to look this up is to use my WinID tool. Now it's this one. If we run it, let me put it a little bit sideways. I know it's kind of small, guys, but if you see right here where I'm pointing with the mouse, it says class. So right now, the way this tool works, when you point mouse to any window, it updates to the information under the mouse. So like, for instance, now it's the edit control, right? If I point mouse to the WinID control itself, it's WinID 3x class. So if I do this with a snipping tool by pointing mouse to it, you can see that its class is Microsoft Windows Snipper Toolbar. So let me hit Shift on the keyboard, and that will make a snapshot inside WinID. As you can see, the number changes to 1 here. I know it's really small, but I hope you can see it. So if you click this 1, and right here is the class. So let me copy it and put it into our program. So this is the class that it's looking for. Now let's try to see if this matches it with the debugger. So again, we have to start over. Because we put a second breakpoint, it should be really easy for us to get to it. Again, this is WinMain. If we let it go again, we get right to this function of interest. So let's step into it and get to find window. Okay, well, let's take a look. First, let's look at the input parameters. So the first parameter is the class name, and the second one is the window name. If you remember our little cheat sheet here, so we're looking at RCX and RDX. RCX first parameter, and RDX is the second parameter. So RCX in this case is this thing, Microsoft Windows Snipper Capture Form, and this is not what we're looking for. So I'm assuming that will return 0. And again, the return parameter is the handle, and if it returns null or 0, it means it didn't find it. And again, I'm using this MSDN documentation. Okay, so it didn't find it. Let's see what else it's doing. Okay, here's another find window. And over here, yep, here you go, Microsoft Windows Snipper Tool. Let me just copy it and paste it here. And yep, this is the class. So in this case, yep, it found the window handle. So I'm assuming, yeah, so right here it's checking if it got window handle. If it didn't get it, it will go here. But in this case, because it did find it, it checks if the window is visible. And in this case, yes, it is. And let's see what it does next. Yep, it checks, is it minimized? Is that this is iconic? And in this case, it is not minimized. It returns 0. And if it's minimized, okay, otherwise if it was minimized, it will do this open icon, which is kind of like confusing, but basically it restores it from the taskbar. Okay, and then it calls set foreground window. When I step over, it will briefly bring our snipper tool to the forefront. So watch this. Okay, and that's exactly what it does. So, and then it calls this ensure window fully on the screen. I believe, yeah, it's some kind of internal function to make sure that, you know, window is probably properly displayed on the existing monitor in case of a multi-monitor system. But in this case, so it sets EDI to 1, calls the destructor for their logging function, and RAX is RDI, which is 1. So it returns 1, and yeah, I believe because we have this one running, it returned 1 like it did in our original example. And if it returns 1, it basically means that it will take that other branch and the app will close. Now, over here, it's kind of interesting. Let's see what happens if we artificially set this value to 0. Let's say to modify a registry in IDA, you have to right-click it, modify value, and let's just set it to 0. And let's see what happens next. So this is called in either case. And yep, so we start registering. So technically, if I continue running, oh, here you go. We got 2 snipping tools. This is exactly what we wanted. So in this case, we found the location in the code how we can actually change this to make it do what we want it to do. Okay, so at this point, I definitely consider myself kind of like 90% done, because all we have to do is just to patch this stuff over here and kind of make sure that EAX at this point is always 0. Now, before we do that, let's look at this function. I double click and see if it does something that would make it that would give us bad result in case the window is already found. So it calls find window, which really doesn't do anything. It checks if it's visible, and yeah, brings it to the front. Oops, sorry. I need to remember I don't need to double click things. Okay, it restores it or brings it to the front. And yeah, ensures that the window is fully on the screen. Yeah, and that's pretty much it. Let's just double click this one. And okay, this one is just the logging function, which they put pretty much everywhere, probably some kind of constructor. For the logging class, okay, monitor from H window, get monitor info, window rectangle. Yeah, that's what they're doing. They're just checking if the window is inside the current monitor. This one is some kind of calculator, offset rectangle. Yeah, they pretty much have this helper class that basically has wrappers for all these Windows APIs. Another offset rectangle. They're just calculating basically how far the window is sticking out. And yeah, and then they call set window position pretty much to move it and return it. So yeah, I don't think we really need this function, to be honest with you. The reason they do all that shifting and changing is because they're not opening the current window. They kind of basically say like, hey, if the window is displayed in some, you know, in the second monitor and you start it in the main one, they bring that existing window to the main monitor. That's what this thing does. So guys, yeah, at this point we can just eliminate this function and yeah, just set this EAX to be always 0. And if you remember, if it's 1, it means that the window is already present. So, and that's when the app closes. So yeah, let's see in how many places this function is used. So if you right click it and list crossed references, and it's just in one spot. So I think the easiest one, instead of modifying this function itself, is to modify over here and just remove it. Okay, that's kind of easy binary patch. Now for that we need to see machine code for this function. So if we go into general and number of opcode bytes and set it to like 8 for instance. So over here you can actually see all the instructions. So if I just select and copy it into my notepad, and notepad here, it's kind of like my little scratch pad where I do kind of like, put all my notes and stuff, which is easy way for me to keep my work notes. Okay, so let me just remove all the stuff this way. So okay, this is what we have, and this is the binary sequence that we will be searching for. Sorry, I need to copy. So what we need to do, we need to replace this sequence over here with something that would always set EAX to 1. I'm sorry, to 0. Now the instruction is very simple. It's XOR EAX with itself. That will always set EAX to 0. It's kind of like a quick and dirty way to do it. The only thing that we don't know is the machine code for this particular instruction. For that we can use any online disassembler or assembler in this case. So let's try this one for instance, and as you can see the machine code is this. So 31C0 in hex, and this is what we need to replace it with, and this part actually has to stay, right? The only thing that is different is that this instruction here, as you can see, consists of 5 bytes, where our XOR instruction consists of 2 bytes. So what we need, by the way guys, I'm sorry, I'm not sure why my Control-C, Control-V is not working. This is how it should be. So basically we're keeping the move instruction. Anyway, so we need to fill in the rest with, well, with some kind of padding. Now the easy way to pad is by using a NOP instruction. NOP instruction is no operation, and the code is 90 in hex. So what we can do, oops, we can just add 3 NOPs to pad this XOR instruction to this length. The reason we need padding is that we can't expand or contract this machine code. If we do so, we will break the offsets inside this binary. So the only way we can do is to use the instruction of the exact same size. And that's pretty much it. So we have to again replace this or this sequence with this, or well, we don't have to technically replace this, we just have to replace this part with this. Okay, well, that's pretty easy to do. So let's get to IDA. Make sure that you close your binary so that you don't you know, that you're actually able to change to save it. In this case, I will not save anything in IDA because it's a pretty simple debugging sequence. Okay, and now let's actually do the patch. In this case, I'm using this HXD binary editor, which I really like. So let me move my binary into it, and I need to find the sequence that I just located before, and that is this one, which is again this sequence of bytes. Now, important for us is that this sequence is, is found only once in the in the binary. So here's the first instance, and let's try the next one. And you see there's only one occurrence, which is exactly what we need. Okay, well guys, at this point we need to replace E8D81 E000 with this sequence. So let me kind of like minimize it down here, and if I move it over this way. Okay, so we start by just typing 31. Oops, what am I doing wrong? Oh, do we have it? Oh, sorry. You see, like, because I didn't open the, didn't close the binary, it tells me that I can't write, which is pretty nice. So I had to close it. Let's see if it works again. So 31, and it works. C0, 90, 90, 90. And again, I'm using this sequence instead of this one. And then it should be 8BD8. Yep, 8BD8. Okay, so this is pretty much the patch that we need. Let me save it. And at this point, as you can see, the hex editor helpfully created a backup of our original. And let's see what we actually achieved here. So just to check, let's move it back into IDA. Kind of quickly go through the process, because again, we know what was the thing here, how to get to the actual instruction. So as you remember, we didn't save anything, so we need to put a break. Oops, sorry. Now what is this thing doing? Okay, we need to put a breakpoint here, and we run. Again, in this case, it is very easy to step through it, because again, it's right in the beginning. Again, this is like very simple example. So let me just quickly go through it. So if you remember, it will register event trace, it will set up heap information. Yeah, it does it twice, and does the heap. There's that constructor. And we need, okay, it's checking for some permission. Then if you remember, it checks some policy. Okay, here it compares the command line. Here creates that mutex that had nothing to do. Again, this is a good example, because if we were looking for the actual CreateMutex here, we would be kind of pleasantly surprised, because again, in this case, it is not using CreateMutex like I assumed originally. That's why I couldn't find it, and that's why I started stepping through it. Okay, well guys, if you remember, on this spot, we had the actual instruction, right? Well, not instruction, we had the actual function. But in this case, as you can see, we removed it and just put XOR EAX, which will always put EAX to 0, and our 3 no operational knobs. In this case, yeah, so this branch here will never be taken. So in other words, we applied our patch. So if I make it run, it should technically start, yep, start one instance. And if I start another one, it starts another one, it starts a third one, and so forth. So right now, we can make multiple snips, right? And all of them will work independently. So I'm not sure why Microsoft did not originally allow this, because I really see no reason for them to limit it. But this is an example how you can modify something and apply, well, in this case, augmentation to existing software using just the binary approach and a binary patch. Okay, well guys, this thing is kind of long, and again, I was kind of like rambling through it, but I basically showed you kind of like a step-by-step approach to creating a binary augmentation or modification. Again, this was part 1. I will record part 2 where we will do additional modification to the snipping tool. So thank you for watching and see you next time.